Hi everyone, welcome to another webinar. Today we have a very exciting topic. We'll be discussing how can you auto-optimize your AI agents using like production data. I am Rishabh. I am an applied scientist here at Future AGI. Before this, I was working at Microsoft, working very closely with the Copilot teams. We built robust evaluation frameworks for the Copilot teams to help them analyze pre-deployment where the agents are going wrong and how can they fix them, and also a lot of frameworks to analyze the post-deployment of the copilots to understand how customers are using it, what are the feedback that they are giving, and how can we use that at scale to improve the copilots. With me today we have Karthik. He is an ML engineer with Future AGI. Karthik, why don't you introduce yourself?
Yeah, sure. Hey everyone, my name is Karthik and I'm working as ML engineer at Future AGI. And I talk to a lot of developers with respect to building AI agents and even the development of ML models. And honestly speaking, it's a very challenging task these days, even though we have got like very intelligent models. Yet the architecture, developing an architecture and making some robust systems is still very difficult for a lot of people as far as I know. So I hope this session might help you. So, anyways, Rishabh, you can continue.
Oh, great. So the way that we have planned this session is that I'm only going to spend a few minutes on the slides just to set up some context. But most of the time we'll be spending getting our hands dirty, analyzing like raw production data and how can we use that to optimize our AI agents. I hope like at the end, like most of you will be able to take back something and optimize your production level agents as well. So the best AI agent in the world only successfully completes 24% of the real work tasks. And this was a report published by the researchers at the Carnegie Mellon University. This was also on a very standard, controlled environment on a standard benchmark data set. But the things in production look really different, right? This was reported by one of the best model at that time, but other models such as GPT-4o had a success rate of just 8.6%, which is really low. So the other day I was speaking to a friend and he was talking about his experience where he was speaking to an AI chatbot, and he mentioned that he had to repeat himself a lot of the times and still the AI chatbot couldn't really understand the context of his problem. And he asked me, like, when we are using such good models, as Karthik was mentioning, that we have such great models that have surpassed the PhD level exams as well, but how are these models still unable to understand simple user queries, right? And that is where the answer gets a bit tricky, because it is not just the model at this point. There is a lot of infrastructure and architecture that goes around the model as well, which needs to be understood very accurately and needs to be orchestrated very accurately as well. And the engineers need to have a strong understanding of these different components for your AI agents to perform really well. There are numerous things in this, bigger wheel that can go wrong, and it becomes like a cascading effect. So if one thing goes wrong, your AI agent will, of course, output certain garbage. But if all of the things in this cycle are working well, you can expect a good output. That leads us to the deployment cliff, right? 42% of the enterprise AI initiatives, they get abandoned even before they reach production. And this number is much higher, approx one third times higher than last year. So we are all talking about the AI hype, and we see so many people got fired, or different companies are adopting AI at a very fast rate. But the real numbers show a very contrasting difference, where the projects are not able to reach production as well. 46% of proof of concept are scrapped even before they reach broader adoption. Now, this is not just from the fatigue of AI hype. It is not that people are not believing in AI anymore, but the companies that have deployed AI workflows, they're not reporting a very strong positive impact as well. That is because engineers are not able to figure out the right tricks on where things are going wrong. They're noticing a drop in customer satisfaction rate. They're noticing a drop in their customers, or their customers are moving to a different platform where the services are still more personalized, right? So that is where the gap between, pretty demos and production start coming in, because during demos, these things are tested on very, simulated and controlled environments, but in production, things look very, very different. And that is where your applications start failing.
Yep.
Let's look at some real world examples. We all know about the infamous case of Replit, where it deleted the entire production database. Not just that, when it was asked further about it, it said that a rollback to the previous data wouldn't be possible. But of course, the founder, Jason Lemkin, was able to retrieve the data a couple of days later. So this shows us that these AI agents can fail a lot of the times. I am guessing probably some retrieval engine failed over here, which is why it couldn't, give the correct answer. But they will also give these answers very confidently, which will make the engineers doubt themselves that, things are performing well, but they never know that these things are not grounded in facts. Another such example is that of NYC chatbot. NYC had launched a chatbot which was supposed to help businesses navigate certain city regulations, and it came up with completely, illegal advice where, investigators marked it as dangerously inaccurate. It told the landlords that it is, okay to discriminate amongst people based on their source of income, which is completely illegal in New York. It gave completely wrong answer to the same question 10 different times to 10 different journalists. Now, what is more alarming over here is that, it gave the same repeated wrong answer, right? Now, why was there no check in place to understand what was going wrong, and why wasn't this fixed in time? The first couple of times that this happened, this should have been fixed. But because there was no check, and again, maybe some case of retrieval failing, or the context not being processed correctly by the LLM happened over here, which is why it consistently gave a very incorrect answer. So why wasn't this monitored and fixed in time, such that 10 at 10 different points of time it was giving the same wrong answer to the users? Another such case is that of McDonald's McHire AI called Olivia, which was supposed to process certain applications, but this was a case where the infrastructure around AI failed. So this AI agent was exposed to a lot of PII data for about like 64 million job applicants. A lot of PII data was exposed. Now a simple prompt injection attempt to this agent could have exposed all of this sensitive data to anyone who was making that attempt, right? So at this point, prompt injection is the number one vulnerability to your AI agents. To the point that OpenAI has claimed that it might never be possible to solve prompt injection completely, because at this point you can never track from which source the prompt injection attempts are coming in. It can be via text, it can be via photos, it can be via image, via videos or audio as well. So it gets really difficult to track all of that. Now, 73% of the production AI deployments tested have prompt injection vulnerabilities, and 83% organizations that plan to deploy agentic AI, only a small percentage is very sure that that their systems are really secure, and a high percentage of these have no prompt injection defenses in place. There is no guardrailing in place to protect against such attempts altogether. The other problem here is that the prompts that we are using for our agents, they are production grade prompts. They are being used in production systems. But unlike traditional software engineering, there is no production level validations or versioning of these prompts happening. So I've seen product managers maintain like 10 pages of different prompts on a Google Doc, but there is no versioning on these 10 pages. So you don't know like what is breaking. So they understand that, okay, something has changed in their production data. They'll maybe make a few lines of changes in the Google Doc and send it to the engineer, or just send some feedback over a Slack message, and that is pushed to the production level application. session with no validations in place on how it is affecting the output of your agent, right? And 10 days later, something might break in the system, but you will never understand that it was because of this prompt change that had happened 10 days before that there is certain degradation that is happening. So this is classically being called as prompt drift or policy drift, but currently there is no way to for the engineers to track that due to such minute changes in the prompt, it is causing such, large problems later. And then people are trying to change the model to a certain better model, trying to make certain adjustments and how the output should look like or process it in a different way, but they're unable to track from which version or from which change in the prompt is this, getting affected, because there are no validations in production level to catch these things. Now, why is all of these problems happening? Your agents, they still keep working. They'll return a perfectly well formatted answer with a lot of confidence, as I already mentioned, but this answer might not be grounded in any context at all. I've seen, large dashboards at AI engineers computers which show that uptime is 99%, latency is really low, tokens use is really low, but nobody's tracking, was the answer accurate, how was the hallucination rate, the context that was retrieved, was it being used by the end level LLM or not, what was the prompt injection attempts that are there. These things are currently going untracked, and the gap that is here is every tool in, traditional observability was built for systems where working is equals to correct output. But because these AI agents, these are non-deterministic probabilistic systems, there are completely different questions in this context that needs to be answered. There is a completely different level of monitoring that we need for this case. Now, because these things are not being monitored well, I would say a lot of, treasure is being lost, because even if your chatbot is having maybe 1,000 conversations per day, you're losing like 30,000 labeled samples for a month, right? Because this data is really rich. You will know exactly the query patterns that your users are using in productions. What are the queries that is making your AI agents fail? Are there certain edge cases where your workflow is completely breaking? What is the language of how the user is interacting with your system? And more importantly, this will also inform you of the next 1,000 or 10,000 test cases that your system needs to go through before it is put into production. Right? If you're not logging all of this, you're missing out on a gold mine of data. Karthik, do you want to add anything from your experience?
Yeah, like honestly speaking, in the world of machine learning or data science, labeled data is like, yeah, as the picture says, it's a gold mine, honestly. Discarding that is a very huge loss. As someone who's working in an organization, for example, like even like let's say B2B SaaS, if we take an example, if one of your clients just comes up and says this is not working, that wouldn't help you actually. You would like to have a very good observability for your system. And in traditional SaaS, we had tools like let's say Jaeger, Tempo, etc. Right? So in that we were able to catch the failures. Most of them is just service-based failure, DB failures, or API failures at the worst case scenario. But in AI, a successful API doesn't mean a successful request sent. There could be some wrong answers, or there could the answers might be hallucinated, for example. So that all that needs to be taken care of and monitored, even annotated, so that you could make more better systems.
Right. Now, what businesses need to build AI reliably, and I had spoken about this in our previous webinar as well. In the last webinar, we had focused on the development phase, where I had mentioned that businesses need to come up with robust evaluation frameworks. They need to define the key performance indicators for their business. So that would mean that if you are having a chatbot system, what are the customer satisfaction rate looking like? Then there would be certain quality metrics. So for a chatbot, that would mean that how is the conversation quality? What is the coherence in the conversation? So these sort of metrics. And then there are your system metrics, such as what is the latency, what is the input output tokens, and all of those things. You want to simulate a lot of different edge cases to understand during development where things are going wrong, so that you can make that better pre-production itself. But in today's webinar, we will be focusing on the production part, where you have to enforce a real-time monitoring system, where you can observe your AI agents on live production data, have a constant evaluation loop over that, and use this evaluation feedback to optimize your agents to like prevent any sort of agent drifts. Finally, to secure your application, you want to have a guardrailing system in place that could protect against cases such as prompt injections or prevent certain toxicity outputs. Now, as I said that earlier, when I was working in different organizations, all of this was done via manual intervention or human iteration. And still, a lot of organizations that we speak to are doing this manually, where there will be like a monthly review of the data that is coming in, that would be labeled. Engineers would try to understand that data and then make adjustments to the prompt. But the scale at which we are dealing with today, this slows down your system quite a lot. To match that pace, we need to build like very reliable, scalable systems that can help you auto optimize your AI agents based on how it is performing in production. For that, you could use a platform like Future AGI, where we provide all of these features out of the box.
Yep.
So that was it with the slides. I now want to move on to the demo, which is going to be the heart of today's webinar. For this webinar, the demo that we have planned is that of a simple voice bot agent, where these voice bot agents are being used across the industries for insurance selling, or for debt collection, or for a lot of different other things as well. The use case that we have here today is that you can call up a restaurant and place an order over a call, or you can also imagine this in a drive-through, where you can place an order on the POS systems. So let's see how this works. Can I place an order for a turkey sandwich?
I'll help you create a turkey sandwich. Let me start by adding a turkey sandwich to your order.
Now, what happened here is there are three major components. First is the STT, which captured my voice and converted that into text. Then we have the agent, which processed all of that and took certain actions to place the order. And finally, we have our TTS systems, which converted the text that was produced by the agent into speech. We'll look at the code briefly. I've created this agent using LangChain. What I have done is that the agent has access to certain functions like add to order, confirm order, and then it has the three components. The STT stream takes in my voice and converts that into text. That is then fed to the agent, which takes certain actions. That is the agent stream. And finally, the agent produces certain output, which is then fed to the TTS stream to come up with the answer, to come up with the speech. Now, to monitor this over live production data, what I've done here is implemented Future AGI's LangChain instrumental, which, using just one line of code, I can get all of the traces on the Future AGI platform using OpenTelemetry. On top of that, I have built the guard railing system using Future AGS Protect. I have defined certain guard railing rules such as content moderation and data privacy compliance. And finally, for prompt versioning, I've used the Future AGS prompt workbench, where I have just mentioned that I want to use the prompt that has been tagged as the production prompt. So all the versioning happens directly on the platform. And if I am using the production tagged prompt, I can directly fetch the prompt from the platform that has been versioned, and that goes in everywhere to the agent. So this is how the agent looks like, and from here we will see how can we simulate like real world calls, track all the monitoring, get all the monitoring systems in place, and use that data to improve our agents. Over to you, Karthik.
Yeah. Okay. I'll share my screen and show you how the details look in the future AGI platform. Just give me a second. So what we here have is a prompt workbench basically. So as Rishabh said, right, how prompt versioning happens in normal teams these days is just they write Google Docs, then they give it to their teams, and then afterwards what happened is code commit happens, and we don't have a way to track those prompt drifts or those model drifts actually. So this is a problem when there are silos in the team and collaboration doesn't happen properly. If I so this prompt workbench doesn't act just as a playground where you just play around with the prompt and edit things, but you can also keep tracking of it using open telemetry tracing. So let's say I have a production prompt, I can just track how my input tokens are, how the output tokens are, and they all of those metrics I can just keep a track of it. Yeah. And similarly, we have a versioning system also. Like first I made a very simple prompt, then I upgraded it to a bit. I'll show you how. So first I'll just show you how the tracing happens. It's very simple to be doing. Basically, you have to add a register function where you register a new project, and you have to choose one of the orchestration layers that you use. We use LangChain, so we'll be using this LangChain instrumenter, which will be auto generating the traces and sending to our platform. If you see, the data will look like this. So there are traces being generated. One is guardrailing and other is the agent's traces basically. Okay. There are other ways to configure tracing. Like for example, you can add sessions also. In sessions, basically you can configure all the chats into one particular chat session basic. And you can also configure users. So for example, when I said, right, one of your users might have put a complaint that some aspect of the agent is not working, you can just directly pinpoint it. So this is how you can basically log the traces and check how things are working. If I open sessions, for example, there are multiple sessions which I can keep track of and check where my agent is basically failing, like is it working or not. But one thing to be sure, when we know in which cases the agent fails, there's no way to replicate those exact scenarios where the agent failed, right? So for that, what can we do? In future AGI platform, we allow you to replay the sessions if you select those sessions basically. How does the replay works is basically we create a lot of scenarios, and after that, those scenarios, I'll just show you. Let's say you can check the agent's prompt, you can check what kind of personas you want, or you can customize other instructions. So what are these scenarios? These scenarios are nothing but a part of our simulation module. So before shipping to production, before you know where the problem is, you will have to first test it out, right? In traditional SaaS, we have some testing platforms like, let's say, Jenkins for CI/CD pipelines, or let's say in Python, we have a PyTest modules, right? But that doesn't work in your agents platform. You need some kind of simulation to be done by a simulated user, where a user comes and talks to your agent. Can that be done by you? Yes, of course. But would you like to do it and like do hundreds or thousands of conversations to your agent? It is very tiring for you, and it is very resource heavy. So simulation solves that problem.
Karthik, before you proceed, I have a question. So, how would you select, or how would you know like which sessions are failing and which sessions do you want to replay?
Okay, so there are two ways. One is using evals basically. Let's say we need some kind of objective metric, right? Like there are some success criteria, success metrics. For a RAG systems, it might be some chunk utilization is proper or not. Or let's say for conversations behavior, we need toxicity checks, or tone is proper for our users or not. We don't want an angry agent, right? So this is where evals come in place. In the platform, we have a lot of evals, for example, And we also allow you to create your own evals, so you can define your own success criteria for your own agent.
Got it. Okay. So, if I understand like this correctly, the way we do this is that once we have tracing enabled on our production data, we start getting traces on the future AGI platform. You see using evals which sessions are failing, right? And
Yes.
then you could replay those sessions based just to like see targeted sessions where things are failing and understand based on scenarios so that you can make improvements to your system.
Yes. So let me just show you how we can simulate those exact conversations again. So first of all, what we have to do is we have to create an agent definition. Basically, tell the platform what kind of agent you want to test on. Okay. Is it a voice agent? Is it a chat agent, for example? So here are the details for my agent. We ask for the phone number or and the agent system prompt basically to generate scenarios. After that, we can generate scenarios from the agent definition itself. If you see, we allow a lot of ways to generate those. One is the workflow builder, which will give you a state management graph, which will automatically generate the number of scenarios you want for your agent. Otherwise, let's say you have some kind of SOP or some kind of script that you want your agent to follow, like a sales SDR agent, let's say. So that can also be done. Or you can use your own golden data set to test your agent on.
So this is in addition to the scenarios that were created using replay sessions, the sessions that you think might be failing based on the evaluations.
Yep. So if I open those replay scenarios, right, they will look like this. So we'll have a persona, we'll have a situation and outcome for you to review so that you can check later that these are the scenarios that we will be testing our agent on, right? And as you can see, this is what the graph looks like. So there will be a huge flow from start here to finish, and the walk can happen from point A to point B anywhere. Like there will be a lot of walks that can happen in this graph, right? So this is how the graph looks. And let's say if you want to edit it out, you can edit it out. How in agent orchestration platforms it works, right? This is very similar to that. And you
Okay,
can
so
also,
what happened here is that based on the session, a lot of different scenarios were created just to simulate those targeted sessions which had failed.
yes.
Now, you would run tests on all of these scenarios to understand, to further stress test the system.
Yes. So before coming to that, we also have something called personas. So what is personas? Ideally, basically your users, how your users will behave to our agent, like what kind of profession they have, what is the location of their uh, phone call, where are they calling from, for example. We also have accents, communication style, personality, like let's say there's some anxious, there's some angry personalities, etc. Even the way they talk is what we can customize, even the language also, like speed, or if they have some are working in a very noisy environment, so we can also configure that. So this is what essentially the scenarios are basically.
Karthik, we have a question. Did Sudhama is asking, did you add persona for each scenario while creating the scenarios?
The scenarios were auto generated by the platform. Let's say if you want to add some particular scenarios, like let's say you want to stress test on some angry personas, you can do that also.
Okay,
Mm. Or a particular accent basically.
got it.
Mm. That's why we have a personas tab where you can check what kind of personas you want and you can create your own persona uh, for stress testing. Next comes the part of simulation where it all comes together. I'll click on create simulation. So here I just add the details of my simulation that I want to do on, and then I can choose scenarios and the evaluation stack that I want to test my agent on. So I'll just do a dummy to show how it works. I can select the number of scenarios and I can do a multi-select too. Note that only the voice scenarios can be configured here, since my agent is a voice agent. But let's say if my agent was a chat agent, I have to create separate scenarios for that. And then I can add evaluations here, basically. Again, I will recommend to use groups. Groups are basically uh, evaluations clustered together for a use case. So we have some dedicated groups, let's say debt collection agent evaluation, or a sales agent, or conversational agent. And this is my favorite group actually. It has the all the success criteria for a conversational agent, and which is what our voice agents are. Now coming back to the simulation part, I'll open the sandwich agent, the agent which you made, Rishabh. So this is what the stress test is. I'll just have to click on the run simulation and it will start calling to my agent and start talking to it. Just like how you would typically test an agent, where you just start talking to it, right? So this is where the fun part is. Like, it is making our life easier. We don't have to do hundreds of calls ourselves, like hire tens of people who will be doing the calls. Instead, the simulations will do the calls and try to break our agent. So as you can see, if I click one of the simulations, we'll have the success criterias, how the agent performed. So it performed very badly on the first trial. If you see the CSAT, the customer satisfaction score, is very low, and even the metrics, right, they are all red, and we can review it all. Like, even the transcripts are there, and we can just quickly review what went wrong if we want to do a manual review and annotate the label data, right? So this is how the simulation works. But what is the next step essentially? Rishabh, would you like to?
Yeah, so let's pause for a bit. We'll also take some questions.
Yeah.
But just to summarize everything so far, what happened was we took our voice AI agent system and integrated Observe over it that does real-time monitoring. Based on few evaluations, we figured out like certain sessions that are failing. We chose those particular sessions and then created a lot more scenarios to stress test our system just on those particular kind of questions. These can be considered as edge cases or workflows that your agents are not prepared for. Now, once you have tested your system on like a lot of more cases based on the same situation, you can understand the customer satisfaction rate and other metrics based on those particular questions itself. So in this case, we notice that the average CSAT rate for those particular sort of sessions was around 4.8, right? Now, based on these evaluations, we will see next that how can we optimize our agent so that they can start performing better on our production data.
Yes.
Before we proceed to that, let's take a few questions from the chat. Burra is asking, how do you ensure there is no vast difference between production data and simulated data, as the production data is based on geographical location? So, when we are choosing the sessions, we are tracking a lot of this information, but essentially, what we are doing is tracking the style of conversation that happened and the goal that the user had come in with, right? So, apart from that, once the scenarios are created, each of them are linked to a certain persona, which can be based on certain geographical location. We provide complete customization for that. If you restrict certain geographical location, all the personas that are simulated will be within that specified geographical location, and it will behave accordingly. Hitesh is asking, can the simulation be in other Indic languages? Yes, these can be on any Indic languages. We have tried them on many languages. We have a lot of customers in India as well using it for many Indic languages.
We also support Indic accents, so there will be a difference between Bengali and South Indian languages if
Yeah.
you try this out.
Another question from Hitesh. You create persona, then situations are generated automatically, then flow testing for each case. So all of this are done in parallel. These are not sequential tasks. If you give a certain persona to follow, that will be followed during scenario generation. But basically, persona scenarios, they're all generated in parallel and not sequentially.
Hmm.
Jiva has asked, this tool is kind of agent management where we can control how the agent should react in production and how we manage the agent success in runtime. Is this what your future AGI product does? Yes, that is one of the things that you can, manage your AI agent systems in production, get a feed of that, and then, replay sessions based on that as well.
Yeah.
The follow-up question is also just wanted to know how are you planning for token cost optimization for repeated patterns in your agents? Karthik, do you want to talk about repeated patterns?
Yeah, sure. So as we like I said, right, we have to first log the sessions and the users so that we can start noticing a pattern basically. We also have an annotation module in the tracing part itself. I can show that. Again, annotations and evaluations can go hand in hand. Annotations is basically human reviewed systems, and evaluations are the automated part for the metrics. So after you click on annotate and let's say you add annotations and evaluations, you can start filtering those patterns, those repeated patterns. Even our current evaluations have those kind of situations. For example, the one I have configured, right, I can show them. So there's a loop detection, context retention, query handling. So these actually give you output in labeled responses. Those are not Boolean or percentage based evals. If I show you the results, for example, the customer agent loop detection, right? There are some labels like never, frequently. So you can identify the repeated patterns as you mentioned. After finding that, you can start implementing some kind of mechanisms like cache control is a very simple one that comes into my mind, right? A lot of providers, let's say even Anthropic or even OpenAI, they give you privilege to do the caching part. So I've heard that you just have to add a basic parameters where you want to do the cache control. With that, you can start reducing and optimizing your tokens. Rishabh, anything you would like to add?
No, I think we can move back to the optimization part.
Yeah.
So far we saw that on production data, we got a CSAT of 4.8 based on the replay sessions and the scenarios that we created. Now we want to improve our agents from here.
Yeah. So as you can see, here's our magic button called Fix My Agent. If I click on that, right, I'll start getting all the summary where my agent went wrong. It's the summary not only gives me the prompt level, but also infrastructure level. Like it just says you should reduce your response latency, maybe start using WebSockets instead of using REST API, or maybe mitigate interruptions and verbosity. Like as you can see, the customer satisfaction score was very less in this because we didn't implement a VAD, if I remember correctly, at that time, right? And these are the like prompt level issues that we found, and this is all identified by the system. Now, what is the next step of it? Is first
Can you
fixing.
also walk us through some of the prompt level issues that were identified?
Yeah. So one is implementing a structured system prompt. Maybe try to add your XML tags. Yeah, exactly. That's what we did. Since we were using a very weak model, if I remember, it was Claude 4.5 Haiku, which is the like a low latency and very cheap model, right? So prompting them using XML tags or adding some kind of structure format, like maybe use pydantic format, is one of the solutions. What the Fix My Agent tells us to do. Uh, we also tell you how the branches, the scenario branches, right? Where it failed, like what kind of flow it will be breaking on.
So in the scenarios, we follow the branches that Karthik showed earlier. There were a lot of different possibilities over there, right? So we also give insights over each of the branch category, which are the particular branches that need immediate fix with high priority. So for example, improve objection handling, right? So if
Yeah.
the customer is objecting to certain things that the agent is saying, the agent is not handling that very well. So that is a suggestion that we are making, that you need to improve objection handling in your agent. Or for example, fix unstable call termination. So the calls are being terminated very abruptly. There is no customer satisfaction on how like the order has been placed and you will receive it in a couple of minutes. So that is very abrupt. So that is also an immediate fix that we are suggesting that you should make.
And like I would like to highlight that there's this off-topic system probe, right? So one of our simulator actually tried to ask it some philosophical questions instead of ordering food. So that's where our agent started breaking up, if you can see. So this is what we identified the issues were, like what fixes we need to do. And again, if you can see, there's one another button called optimize my agent. Rishabh, would you like to tell about it?
Yeah. So in Optimize My Agent, we have integrated a lot of open source optimization algorithms that are there. Now, we want to move from a time where, this was just based on guesswork. You are trying to make certain small tweaks in your prompt and then trying to see if things are improving, but there was no calculated way for you to make certain improvements in your prompt, right? There was no measured way for you to see that things are validated and things are improving over time. So what we have done here in Optimize My Agent, that a lot of these open source algorithms that have recently come out, such as GEPA or Prompt Wizard, that makes very calculated changes in your prompt. It can turn a very small prompt into a large system level prompt, which has a lot of instructions in place, such that it prevents a lot of hallucination. It uses the right context at the right time and comes up with a much better version of the answer. There can be still cases where it does not make a lot of improvement context wise, but it'll polish your answer much more, such that it seems that a professional is providing a very personalized experience. So these are available right on the platform. You can choose different optimization algorithms based on your use case. So for example, GEPA works really well with large amounts of data, but if you have small amount of data, something like a Bayesian search would do. Uh, and you configure a few things over here, such as the teacher model, the student model. So these are models that will help us improve the prompt based on however the algorithm is configured.
Coming back after you see the optimizations being done, you can just actually go back to your prompt workbench and start writing a new prompt. If you can see, I have a V2 where it gave me a better prompt and it was a well detailed. If I show you the V1, right, it was a very simple prompt that I started with.
Yeah. So here we had started the agent with a very simple prompt that you are a helpful sandwich shop assistant and these are the available meats for you with these available cheeses. But it was failing for a lot of these cases. As you saw, the customer satisfaction rate was 4.8. Then for this particular use case, we used a Bayesian search optimization algorithm, and that did a few iterations over the prompt and improved it in some time. So Karthik, can you show the improved prompt as well?
Yeah, let me just restore that.
Yeah, so now you can see that it has added a lot more things in the prompt. This was basically to, avoid hallucinations or any sort of handling of edge cases. For example, as we had mentioned that it was out of context questions, it wasn't able to handle well, right? So it has increased it has, made the prompt much better now. So we use this prompt in our production system. And Karthik, now can you show the re-simulated runs?
Yeah.
So over one iteration itself, we can see that the customer satisfaction rate, which was earlier 4.8, has now increased to 5.6, right? And we did not have to do anything at all. What we did was we chose a few sessions that did not, perform well in our production environment. Using those sessions, we created a lot more scenarios, stress tested our system, got a CSAT of 4.8, optimize a prompt, and now got a CSAT of 5.6 with just one iteration.
Yeah. So it's a like 18% increase, I believe.
Yeah.
As you can see, even the eval metrics have been increased a lot. It was essentially in red zone, now it's in yellow zone.
Yeah, so some of the very important metrics like prompt conformance, right?
Hmm.
Earlier, there was a lot of drift in how the agent was answering the user's question, and it wasn't adhering to the prompt instructions that we had set in. But after using the optimization, the prompt conformance increased a lot. Then the agent language handling, which sees whether customers have like different sort of dialects when speaking to your AI agents. So how well is the AI agent able to handle that as well? Or what is the context retention of your AI agent? Is it able to remember something from earlier in the conversation, which
Yes.
becomes very important for something like that has to accept restaurant orders, right? So all of these metrics have gone up significantly, around 20% over just one iteration, right? And if you spend more time and use more particular things in that optimization algorithm over time, with a lot more production data, you can make very targeted improvements in your prompt, and you will start noticing differences in your production level application.
Yeah. So I would like to add, like, what happens when you deal with a large amount of scale, right? So this is just, as you can see, just 20 calls is what we have done, because we just selected like 4 to 5 sessions and we generated these number of scenarios. But when we deal with a production level of data where sessions are in hundreds, even thousands, then at that point, this kind of stress testing becomes more important because it gives you objective metrics and you can see a lot of improvements if you start following these kind of practices.
Great.
Hmm.
Karthik, anything else that you want to recommend to the engineers on how they can use the production level insights to improve the agents?
Yeah. I think I can talk about Agent Compass. We have another feature in our platform. So what happens to your traces is, right, these production traces, if you can see, you can check the conversation, but honestly speaking, let's say these LLM calls the spans. But checking all the conversation can be very bothersome for the engineers, like manually reviewing it. It's not like your traditional SaaS platforms where you can just search things and check them out. So what you need is some kind of a cluster which will be checking some targeted errors that your system might have, which is where Agent Compass helps us. Agent Compass is nothing but an agent living in future AGI platform that checks the traces and starts forming and analyzing some insights around that trace where the possible errors can come through. And
So
these are in
what
the feed tab essentially.
what Agent Compass helps you with is to, it's the zero config evaluation system. You do not have to go through all of the traces. What it does is it'll analyze all the traces and cluster, similar patterns so that you can see what is breaking in your system. And based on that, choose the sessions that you now want to replay and simulate so that you can stress test your systems.
Exactly. You can just see and check, and we also give you a recommendation like what should be an immediate fix or what could be a long-term fix for this.
All right.
Hmm.
Think we are almost towards time. I will quickly conclude and then take some questions.
Yeah. Stop sharing the screen then.
So, what I want to for you to take away today is that you really want to like instrument your AI agents so that you can understand in production the things that are breaking. So we saw certain sessions on our platform, and you can choose the sessions which you saw are breaking so that you can simulate a lot more scenarios and stress test your system on that, detect using something like agent compass, or go through some traces to understand what are the common patterns on which your systems are failing, then further stress test it on a lot of similar scenarios based on the evaluations that you have configured. Use these evaluations to optimize your system. Use the feedback from these evaluations, and finally also have like certain guardrails in place to prevent from cases such as data privacy or prompt injection attempts. We would love for you to join our community. Please do join our Discord community, and we'll take some questions from the chat. Animesh is asking, I have had scenarios where the agent's system prompt remains the same, but it randomly shifts between correct and wrong answers. Sometimes it answers correctly and sometimes it answers wrong. How to address this type of issues?
Mm, Honestly, there are like multiple ways to tackle this situation. One is what kind of model are you using? Is it a thinking model or a non-reasoning model? Because let's say for a thinking model like by OpenAI, GPT-5, for example, they don't have hyperparameters these days, as far as I know. But for the non-reasoning models, right, the temperature acts a very important hyperparameter there. Like a lower temperature might give you a better answers.
Yeah,
And
I
then
think to ensure consistency, to on your prompts, like to get similar answers each time, I think temperature is the way. Like have as low temperature as possible so that there is some creativity in the answer as well as they remain consistent over different runs.
yes. And another thing is about the context. You have to maintain the context properly, like all the chat history. If, for example, you have some kind of summarization done, you have to do it properly. Otherwise, there might be an issue.
Okay. So Sudhama is asking, how do you ensure the prompt doesn't get too large or complicated with all learnings from the simulation? So this is actually a problem with some of the optimization algorithms. I think we were discussing this sometimes back. These optimization algorithms can sometimes overfit on the examples that you have provided. So you need to use them very carefully. So these are similar to how you would train traditional ML models. If you're overtraining on your data, it can include a lot of things in the system prompt and then start overfitting on that. So you want to do some iterations based on like a lot of evaluation so that it can take that feedback, not overfit, but also supply it with a lot of varied examples as well.
That's why the importance of testing at scale also comes. Like you don't just have to test in 5 or 10 scenarios. Maybe you have to go with hundreds of scenarios from production data, etc.
Yeah. Shiv is asking, in the V2 prompt, there were not a major changes, but it looked like it gave a bunch of examples. But is it actually, does it not overfit? Yeah, sometimes it can overfit. So you need to, check for that so that you have a lot of varied examples and it can, not overfit on the examples that you have given.
Yeah, in our case, it acted as a few shot prompt basically.
Is the recording available after session? Yes, it will be. What LLM model have you seen work well for voice agents in terms of accuracy, following instructions slash context? So for voice agents, I think the GPT models currently they are doing well. I have personally used it for some of the projects and I have found them to be performing quite well. Karthik, do you have any suggestions for certain models?
When it comes to voice models, honestly, like we would like a low latency model. So reasoning models are very bad at that point. You would like a non-reasoning model,
Yeah.
or at least turn the thinking off.
Okay. Animesh is asking, how does future AGIs protect differ from open source guardrails? Uh, guardrailsai.com. So, Karthik, do you know about guardrails AI? What I can tell you is that for Protect, we have fine-tuned a lot of open source models, and we have also made our text models publicly available on Hugging Face. We have published a research paper as well. You will find it on Archive. We can post a link on the chat as well. So we have shown in the paper that we get state-of-the-art performance on the metrics that we have built in for the Protect model. Karthik, like, do you know of any differences?
If I remember correctly, like I might be wrong, but guardrails AI don't provide multimodal support, while our model does. Native multimodal that too.
Okay. Nimesh has asked, how would you define test cases for biological data, and what would the hallucination rate be calculated? How would the hallucination? I think for biological data, things are always a bit tricky. So if you are, having if I imagine it as a healthcare voice AI assistant dealing with some biological data, you need to like have it in a way that it can, deal with a lot of, privacy compliances, and it can, of course, be vulnerable to prompt injections. So those sort of things you have to make sure. For biological data, use certain models that are specialized and fine-tuned for answering biological questions, because that is also a very slippery slope, and you might, not get very specialized models for that.
If I remember correctly, MedGemma is one of those models that you mentioned, right? By Google. It's open source, so you do check that out.
Yeah. Okay, so last question. If the latency is bad because backend resources, how do you make sure your agent response is proper and good to convince customer? So there are a lot of things here. Basically, the agent latency for voice agents depends on like three different things: the STT and the TTS modules that you are using, and the agent's own processing time. So for STT and STT modules, there are a lot of smaller models as well. If you are not using a very niche language, if you are dealing with English, you can use some of the smaller models because they perform well and they have a really low latency as well. But for agent processing, there are a few things that you can do. For example, if it is not a very complex task, try using a smaller model, or only use a larger model that takes higher latency for the planning. But for the execution, you can again use smaller models, and that is how you save some time on the entire process.
Yeah.
Okay, great. I think we have covered most of it and we are on time. Thank you everyone for joining today's session, and thank you Karthik for showing us the demo. Uh,
Thank you, Rishabh.
I had a great time, and I hope some everyone learned something today on how you can take your production level agents, simulate sessions, and then improve your agents.
Yes.
Thank you.
Thank you.